Okay, welcome to video 7. Here we're going to talk about arithmetic and geometric sequences again. So no new information here, just going over the same thing that we looked at in the previous few lessons. So when you think of arithmetic, remember that they need to have a common difference. When we think of geometric, they need to have a common ratio. So you always just need to figure out what is the pattern and then get the formulas from your formula sheet, and then you can just fill in what you know. So we'll look at another example. The number of triangles in each picture below represents a sequence pattern. So when we look at the triangles here, there's 1, 2, 3, 4. So this is 4. And then when we look at the next one, there are 6 triangles. Counting the next ones, I see 8 triangles. And finally, 10 triangles. So now I need to ask myself, well, what is the pattern? How am I going from 4 to 6 to 8 and to 10? So if I think about that, I see that I can add 2 each time. 4 plus 2 is 6, 6 plus 2 is 8, 8 plus 2 is 10. So that means there's a common difference. And now when I know there's a common difference and I need to write a formula, that tells me that I'm going to look for the arithmetic since there's a D for my situation. So the arithmetic sequence formula is the one that has a D in the formula. So I will write the formula first. So here's the formula, the way that it's written on the formula sheet. A sub n equals a sub 1 plus n minus 1d, and then I'm just going to fill in with all the things that we know. So when I look, I knew the first term was 4, so I put in 4 as my first term, plus n minus 1 from the formula. The common difference was 2, so I put the 2 there. It's adding, that's why it's a positive 2. And remember to put that in parentheses, because if it is a negative, we want to know that it's multiplying by a negative 2, not just subtracting 2 at the end. Then the question says how many triangles will there be in the 12th figure? Well, this is an input or an n value, so I'm going to repeat my formula, but now instead of the n that I had in this step, I'm going to replace that with a 12. Then it's just a job for our calculator once you've subbed everything in. So we've got the a sub 12 equals 4 plus 12 minus 1, close parentheses, times the 2. Then I can just put that all in my calculator and I get the output of 26. The next question says, what term will have 56 triangles? Well, what term, that means I don't know the n value. The 56 then must be, if it's not the input, it must be the output. So I'm going to replace the a sub n with 56. Now we have a couple options for this. We can think of it as what's happening to n and do the opposite in the opposite order. Or if you wanted to, you could distribute the 2 into the parentheses. Then we don't have parentheses anymore and you would just combine like terms and solve for n. I'm going to go ahead and do the opposite of what's happening to n. So if I think about it, n is being subtracted from 1, then multiplied by 2, and then finally we would add the 4. So I'm going to start by subtracting the 4. Then I end up with 52 equals the n minus 1 times 2. So now I'm going to do the opposite of what's happening with the 2. I'm going to divide both sides by 2. Then I just moved over here so I could continue my work here. Once I've divided by 2, I end up with 26 equals n minus 1. Then I can just add the 1. When I add the 1 to both sides, I end up with n by itself, and the n is 27. So that tells us that the 27th term will have 56 triangles. Okay, that's it for this video. Just a quick one more example for you to use to then fill in the rest of the questions. Always think to yourself, is there a common difference or a common ratio? And then decide which formula to use for explicit. And remember, when we talk about recursive, we always just look for what in the formula is telling us previous term. Okay, we'll continue this tomorrow. Have a good night.